Welcome to Brain Vision.
This is Chapter 2, Problem 12. So in this problem, we've got two locomotives approaching each other, initially from a distance 8.5 kilometers apart. And we want to find how long will it be before they reach each other. So how much time will pass before they meet. And we know the speed that each train is traveling. So since each one is traveling at a constant speed, if you know the distance that one of the trains travels before it meets, then you can use our trusty average speed is distance traveled over elapsed time. At this point, you'll know the distance, you'll know the speed, so you can solve for the time. So, since this is a symmetric thing and they're both traveling at the same speed, they are each going to travel the same distance when they meet. So they'll each have traveled half the distance, half the original distance between them at the time of meeting. So let's just consider the left locomotive. It will have gone half of 8.5 kilometers, or 4.25 kilometers, in the time it takes for the trains to meet. So we're solving for delta t here, so let's rearrange that equation on the left to delta t. What we're looking for is delta x, our distance, divided by our average speed, and our average speed here is just our constant speed. That's the 95 kilometers per hour. So substitute that in there, substitute our 4.25 kilometers up here, and our answer should come out, we've got kilometers divided by kilometers per hour, so we should get something in hours as the amount of time. And indeed we do. This gives us 0.0447 hours. Now, that's a rather small fraction of an hour, so maybe let's convert that. This is technically a full correct answer, but it's nice to convert that to units that are a little more meaningful. Since it's a small fraction of an hour, we want to convert to a smaller time unit, such as minutes. So let's convert units by multiplying by a fraction equal to 1. Since we know there are 60 minutes in an hour, I can put 60 minutes up top, 1 hour on the bottom. Those hours are going to cancel out. And you end up with 2.7 minutes, which is a more understandable amount of time. So in those 2.7 minutes, you know that the left locomotive, going at 95 kilometers per hour, will travel 4.25 kilometers. The right locomotive is going at the same speed, so it's going to travel the same distance. And since when both locomotives have traveled 4.25 kilometers, they will collectively have covered that 8.5 kilometer distance, and they will both be at the same point right in the middle.